Well, hello everyone, and I know this is early for me, but today is going to be a crazy day. I will still be here this evening, but I just wanted to step in here. I'm going to be trying something a little bit new a little bit later, but for the most part, I just really wanted to hit on certain concepts that's not really GED or acuplacer related, but is something that's helpful, especially for those that are taking geometry. So I really just wanted to step in here just to kind of talk a little bit about measures of central angles and their arcs, and then talk a little bit about inscribed triangles. So, if you know anyone that's taking geometry, maybe you're a homeschool parent, or maybe you're a homeschooler just kind of zooming through TikTok and you need some assistance with measures of central angles, this is the place for you. All right, so when we are taking a closer look, let me zoom in. So, when you have a circle, and in that circle, you have a central angle. So basically the center of the circle. And this is creating an angle. So this angle is called the central angle. The reason why it's called the central angle is because it's involving your vertex is hitting the center of your circle. So with that being said, when you have an angle, and your vertex, the place where it changes direction, is hitting the center of that entire circle, that means the measure of this angle is exactly the same as the measure of its arc. So this arc right here, the measure of the arc, not the arc length, okay, not the area of the sector, just the measure of that arc is going to be exactly the same as inside that circle. So the unknown is going to be 100 degrees. Now, another thing we need to understand that the measure of degrees of a circle is 360. Okay, so that's why when someone says, oh my gosh, he transformed his life, he made a complete 360, that's when you got to correct them. That means he went around and he went right back to where he started. All right. So if someone has made a change in their life, they're basically made a 180 because 180 is half of a circle. So if this angle is 100 degrees and we have a line that's going through the center of the circle, that means that's a diameter. That means that's cutting right through the center of the circle, which it is half the circle. So that means this angle plus this angle should equal 180 degrees. But in fact, they don't give us a measure of this. So that means this has to be 80 degrees. And the measure of this arc is also going to be 80 degrees. All right? Because the 100 plus the 80 gives me 180, gives me half. Hey, Leanne. So, knowing that, that means the measure of this arc. Let me see if I can change up. So the measure of this arc is the angle is half the circle, so that makes that's 180 degrees. So the measure of this arc is going to be 180 degrees. Okay, so that goes for measures of central angle. So this isn't necessarily in the GED. You might, I know you're going to see something like this in SATs or ACTs, but not so much in the GED or maybe even the acuplacer. You might see something like that. I just wanted to come on real quick because this weekend was crazy. So here I am. All right, so let me slide over. So now we have two central angles. One of them is 75 degrees. The other one is 140. And they want us to find the measure of this arc right here. Not the whole thing, just from here to here. Okay, what do you think the measure of that arc is going to be? Okay, so the eye of Providence saying it's going to be 140. Good, because it is the central angle. Yes, Leanne, we got 140. Good. Okay, so we have from here to here, since the measure of the central angle is 140, that means the measure of its arc is going to be 140. And the reason why, because the vertex, or where that angle is hitting the center of the circle. There is a reason why I keep repeating that, because I'm going to show you something a little bit later that's going to be like, whoa, 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 what? So, are we doing multiplication? No. Measure the central angles. All right. So now let me go down to this one. All right. So this time they're giving us the measures of the arc. They want us to figure out what the measure of angle IHJ. So they want us to figure out the measure of this angle right there. So we can take this one or two ways. And here's the best part. These two angles, they're saying they're measured the same degrees. The reason why I know that is you see that little red. Let's see if I can expand a little bit more. Okay. You see the red right here for the angle measurement. They're saying that this angle, IHJ, is the same as IHL. So whatever I get over here, I'm also going to get over there. So now they're saying the arc KJ measures 150. So that means this angle JHK, that equals 150. And they're saying arc KL measures 60. So that means this angle here measures 60. So like I said, the whole entire circle, an entire circle is 360 degrees. We know bits and pieces of it, and we know two of them are going to be exactly the same. So let's figure this out. So we're going to, let me see if I can slide and reduce just a hair. Okay, just so we can get that. So I know if I look at 150 plus this 60, that's going to give me 210 degrees. If I take 360 from that 210, I can figure out the remaining two angles. So we got my 0, I got my 5, and I got my 1. So we're saying that both of these angles is 150. So now, in order for us to get that 150, since you guys are hitting it right, we need to divide that by 2. Because each of these angles is going to be the same measure. So if I divide it by 2, the only reason why I'm doing it this way is because I need some room. So I got 75. So that means each of these angles is going to be 75 degrees. So if I write my answer, it's going to be the measure of angle IHJ, and it's going to equal 75 degrees. All right. All right, good. Nice. All right. So, coming over to this one. So they want us to find the measure of angle JHK. JHK. So we're looking for this spot right here. What are they giving me? They're giving me a little bit of information. What are they giving me? Let's see what you guys have. It's about like 17 of us in here. What are they giving me? Okay, so Leanne's saying 49 degrees. Okay. They're giving me 131, Paulo. All right. Side angle side. Okay. Are they indicating the sides in order for us to get side angle side? Okay. So a lot of people are telling me I think it's 131. Ooh, all right. Sargina, she's saying supplementary. Is it Sargina or Sargina? The first one I say is Sar, the second one is Say. Okay. So I got a 91, I got a 131. Okay. All right. Her, H-E-R, saying 131, 131. All right. So we can take this one of two ways. We could do what we did with the last one. We could say, all right, they gave us this arc measure of 49. So that means this angle measure is also going to be 49 degrees. And I think basically what Sargina said, we got supplementary. So if I cover this part up, segment JL, that's my diameter. And the reason why I know it's a diameter, it's a segment or it's a chord that's going through the center of the circle. So we know if it's going through the center of the circle, that means this side, arc JKL, and arc JIL, they're split in half. They're both equal 180. Hence the word supplementary. That's why I was like, ooh, got excited. All right. So if we have a half a circle and we know that it equals 180 degrees, and they're giving us 49, let's subtract to figure out this missing angle arc combination. So if I borrow, got my 7, there's a 1, there's a 3, and there's a 1. So that means this missing angle measure, which is M, the measure of M of JHK, is equal, trying to see if, make sure I'm not cutting it off, 131 degrees. Okay, good. All right. Okay, so we're getting it a little bit. And if you wanted to, you could have done what we did with the first one. These two right here, these two angles, they're vertical angles. Vertical angles means that they're congruent. So that means I could say, let me use a pencil for this part. I could say that this angle is 49 degrees. And then I could add the 49s up, right? To give me like what, 98? And then take 360 divided by that, not divided, sorry, subtracted from that 98. So if I wanted to, I could have done 360. Oops, a piece of tape right there. And then we take that 98 and we subtract the 2. And we'll get 262. And then I can divide that 262 by 2. And I can also get my 131 that way. Okay? So there's multiple ways of getting the same answer. All right. It depends on how you see it. Okay. Just like with life, your perception, you're going to have your decisions, how you want to live your life, how you want to do things is going to all be based on your perception. So if you saw the 180, half the circle, and you just subtract it by 180, great. If you're just like, oh, okay, we got vertical angles, I'm going to add these two up and then divide by 2 to get these, one of the 2 remaining angles, you can do that. Great. No matter what, you're going to get the same answer. All right? You're going to get the same answer. Okay? That's the measure of angle JHK. That's the proper way of saying it. Okay, so because we're not looking at the value, we're looking at the measure of that angle. All right. For an abacus. Would it be? Maybe you have to remember this one because I'm not sure Lynette's here. But, oh, Anne was here. Awesome. Okay, so if anything, remember this problem and share it with Lynette. Be a great time for an abacus. Maybe that's what we should do. Maybe we should suggest that. That Lynette and I go live together and I'll just do a math problem and then she'll see if she can do it. Oh, yay, Anne. Yes, the middle angle is always going to be your vertex. That's correct. Hey, Joe. How are you? Okay. Let's try the next one. All right. So this time, they gave me arc measures. So since it's a central angle, okay, that vertex is right at the center of the circle, that means this angle is 40 degrees and this angle is 61 degrees. Okay. What else are they showing? So, Nico, why do you think it's 101? Or Richie, teacher, all right, why do you think it's 89? Okay, I'm getting the 89, I'm getting 101. How are you figuring it? It's like I have a feeling that Nico is saying it's 101 because he's adding these 2 angles together. Okay. Okay, so I got a 129, which is a guess. Okay, and we got a 79. Okay, we got a 101. All right. All right. So since we're looking at angle, because remember, we're trying to find the measure of angle YTU. So YTU is this section right here. We're looking for this angle right here. Okay. And someone mentioned it. Who said it? Jonathan. If you guys look to see what Jonathan says, he saw it. Okay. This angle here and this angle over here, they are vertical angles. Okay, they're vertical angles. So we didn't have to worry about, oh, okay, let me subtract that from 180 because then you're getting angle VTU or you're getting angles TXY. That's not the one we're looking for. We're looking for YTU. Here's Y, here's T, here's U. So we're looking for this section here. So since if we add up 40 and 61, we do get 101. And if this is 101 and we got a vertical angle over here, that means our measure of angle YTU is equal to 101 degrees. Okay. That's what you saw. Okay, good. All right, I'm used to having the equivalent angle symbol to guide my eyes. Okay. All right. A little bit of piece of tape. Yes. Don't worry. I know sometimes, and that's what happens, especially when we take our exams, we're just like so like zoomed in, like, oh, I got to find the measure of all the angles. Sometimes it just like you really, before you start calculating, write down all the stuff that you need. Okay. Write down all the stuff that they're giving me and what I need so I can say, oh, I didn't have to do that subtraction and I didn't have to do all that stuff. And then you'll be surprised on how much time you save, and you can use it on harder problems that you want to actually take some more brain power with. Okay? Yes, definitely mark your angles and segments. Don't you add and subtract from the formula? What formula? Because right now we're just dealing with either 180 or 360. Okay, so we really don't even have a formula. Okay, let's try a couple more. And then I'm going to introduce you to the inscribe triangles. All right, let me unzoom quite a bit. And let me flip. All right. All right. So, okay. The types of angles again? What do you mean? You thought it was 57? No. Because I know, the vertical angles and all that. Okay, I gotcha. All right. So, when it comes to where is it? This problem. Okay? We're not looking for VTU. Okay? There's no way that it could be a 59. Because if that's supposed to be 180 minus the 101, that's going to give you 79. Okay? But we're not looking for this angle or this angle. We were looking for this angle, which is directly across from the 40 and the 61. So since we got those two, all we had to do is just add them up, because these two angles are going to be the same because they are vertical angles. Okay. Yeah, they equal each other. Okay, so the list of angles. So you have see if you guys can see that. Okay. So you have your complementary angles. So like angle A and angle B equals 90 degrees. You have your supplementary angles. Which if I drew so supplementary angles is you have your angle A and your angle B equals 180 degrees. And these are vertical angles, which means angle A is equal to angle B. Okay. So those are the three main ones. There's more, but these are the three main ones that you're going to see the most of. So complementary angles, not so much right now with the circle, but as a possibility, especially if they're perpendicular. So if you add the two angles up, hold on for a second. Let me say angle A, angle B. So if I angle A and angle B, if I add them together, it'll give me 90 degrees. Supplementary angles, if I add A and B, they're also called a linear pair. If I add A and B, that will equal 180 degrees. And then vertical angles, which are directly across from each other, they could be directly across this way or this way. I didn't want to put C and D because then it'll get confusing. So I just want to kick with the A and B theme. If they're both across from each other like a V, they're going to be congruent. They're going to be equal to each other. Okay, is that helpful? This is Maryland. Okay, so the alternate interior angles, also exterior angles, does not go with the circle. That goes with two parallel lines cut with a transversal. So that's completely different. Okay, yeah, so that's completely different. The only thing that's completely different. Okay. Yeah, so that's completely different. The only thing that kind of carried itself or that you're going to use for circles are going to be these three. Okay, awesome. All right, coming over to this one. And yeah, and today's session is going to be very short because I just wanted to get this off my chest. Just wanted to get off my chest. All right, so now we have an angle measure, which is an expression this time. So 6x plus 11. And its arc, -7 plus 8x. And they want us to find the measure of angle HFI. Okay. Hey, Lisa, good morning. I know it's not my usual time. I felt like I had to squeeze this one in, and I'm still going to be here this evening. So I just needed to squeeze this in. Ain't no way. Yes, it is a way. All right, because I just had a session and I have another session later on. All right. So, hey, Austin. So, central angle and its arc. If I said that this was 100, that means this arc would be 100. All right. Okay, you're welcome. Should be equal to each other. Yes, Luna. Good. Or sorry, Luna! I saw the exclamation. So, if anything, since they are the central angle and its arc are always congruent, they're always equal. So all we have to do is set those two expressions equal to each other and then solve for x. So we have our 6x plus 11. I think you guys can see it now. Okay. Equals -7 plus 8x. So we're going to solve for x. It doesn't matter where you put the x. It really doesn't. But I'm going to subtract my 6x on both sides because I want my x's on the right hand side. And I'm going to add my 7's on both sides. You can do the cancellation in one line. If I subtract the 6x, these are going to cancel out. That means I want my x's to be by itself over on the right-hand side. So that means this -7 needs to go. So I'm going to add the 7 on both sides so they can cancel out. See how you can do it all in one line? I'm not sure if anyone ever showed you that. So now, let's do the operations. So we have 11 plus 7. That gives me 18. And then we have 8x minus 6x. So that gives me 2x. So now let's divide both sides by 2. So the 2's can cancel out and it will isolate my x. That's exactly what we want. So 18 divided by 2 will give me 9. Okay. Yeah. Sorry. Brian is like, wait, you mean to tell me there's an easier way? You're just basically doing all the calculations all in one line. That's it. All right, so we found what x equals, but we're not done. Anytime you solve, always go back to the original to make sure that you're answering the question. We want to find the measure of HFI. So the measure of angle HFI is this angle right here. Plus, it's being represented. Let me write underneath it. So the measure of angle HFI. And right now, that's being represented by 6x plus 11. But if we're going to solve, we're going to use that answer that we got to plug in for the x. Okay. Get this math off my feed. Well, stop watching. Yes, Kayla, there you go. Every time. And that's fine. That's fine. Okay. It's a sign. Yay, more geometry. Yes. All right. So now we have 6 times 9. That'll give me my 54. Add 11 to that. And that will give me my 65. Thank you, Luna. I'm not sure. I think someone else said it earlier. Hold on. Do some ratios. Not now. Because I'm trying to get this and the other thing off my chest. Because I really got to go in like 20 minutes at the absolute latest. Yep, I think Luna, you were the one that said it. Okay. Not really. Not really. But I appreciate you saying that. So that means the measure of angle HFI is equal to 65 degrees. Okay. All right. So take a look at the next one. I think you guys can kind of see it, but let me see if I can raise it up all the way up. Okay, take a look at the next one. I'm going to zoom in so you can really see it. And I want you to try. I just want you to try. At least try to set it up. Okay, don't put the answers. Don't put the answers up. I just want you to set it up. I'm going to give you like 30 seconds. Don't freak out. Just try to set it up. What are they giving you? Okay, don't put it up so that I shouldn't see anything other than tapping of hearts. Okay, so no comments unless it's like hi. No more comments. Just tapping of screens. And I want you to set up the equation. Okay, do not put the answer up. Just set up the equation. For a sec, sure. I'm going to show the other equation just for a quick sec. Take a picture of it real quick. Go and take it off. And then 3, 2, 1, 0. Okay. Back up to the original. Okay, just tapping of the screen. Nothing else. Oops, let me angle that just a little bit more. Okay. Okay. You guys are coming up with the equation, Mama. I know you just came in. Okay. You're welcome. All right. Okay. So, show me what you think the equation is. Don't show me the answer. Just show me what you think the equation is going to be in order to solve for this. Okay? Just put down the equation that you think it is in order for us to solve for this. Okay? That's all I need. Just the equation. Okay? That's the only thing I want to see right now. Not the answer. What do you think the equation will be? And if you're not sure what the equation is going to be, remember, question marks are always welcome. Okay, you could just put a question mark. I don't know. So, Mama, I know you're probably like, well, what are we doing? Because, you just got here. So that's understandable. But if you happen to think of an idea or a guess, go ahead, put the guess in. If you're completely lost, question marks. If you have a guess, put the question mark at the end of the guess. Erica. Big question mark on that one, though. That's fine. Because as soon as I show you the setup, you're going to be like, oh, gosh, are you serious? Because it's going to happen. It happens all the time. Okay. No one wants to take a guess? No clue, but I'm learning with you. No problem. All right. So this is what's happening. You guys are looking at it as one big problem. Okay? You're looking at it as one big circle. But if I do this, like a partial eclipse, you'll have a better idea of what to do. Okay? Ham's got it. Luna's got it. Okay? If we look at it, because all the action seems to be happening on this side of the circle. And remember, since we're dealing with central angles, the measure of this arc is the same as its angle. Okay? The measure of its arc is the same as its angle. Okay? All right. So now, all we have to do is just set it up. Let me unzoom a bit. And then slide over. So to set it up, we have our 32x minus 3 plus 14x minus 1 equals 180. Okay. All right. That's what you said? Oh, okay. All right. So combine your like terms. Okay. Combining my like terms. Tell me what x will equal. Combining your like terms. What do you think? Okay. So we have our 36x plus 14x. You're saying that will give me 46x. Okay. What about the negative 3 and the negative 1? What would that give me? Negative 4. Negative 4. Good. All right. Equals my 180. All right. Continue on and then tell me the answer for x. what would you get for x? So we got this far. What would you get for x? Okay. Good, Lisa. See if you can divide it. Okay, Nico. Nico's saying 4. There's Michael. See, my life is complete. Look at this. When you can see Michael, Mr. One more. Yes, Michael. Yeah, we're going to need to bring these Roman numerals back. Okay. Papa, we're going to need to take a look. The screen is saying 4. All right. First thing I need to do is isolate my x, which in this case is my 46x. I'm going to add 4 to both sides. So when I add 4, I'm going to get my 184, and it's going to equal my 46x. So now I need to divide everything by 46. So we have our x is equal to 4. But are we done? Are we done? Okay, no. Okay, no. We found what x is. But if we go back, we're looking for the measure of angle XST. Here's XST. So we're looking for the measure of this angle right here. But we know that its arc length is exactly the same as the central angle. So I need to take my measure of angle XST, which is equivalent to 32x minus 3. Okay, it's spring break. Well, while you're up, you can, trust me, you are attracted to the torture. I didn't tell you to stop in here. I did not come over to your house, wake you up, put the phone in your hand. You're probably looking at the phone with one eye right now, one eye open. I didn't do that to you. But I'm glad you're here. So substitute this 4 in for the x. Okay. All right. No problem. You do the same. All right. So we have 32 times 4. Okay. That gives us our 128. Minus the 3. That gives me my 125. Okay. And that's who was the first person that said that? And that's what Papa said. Okay. Okay. So that's what Papa said. So we got the measure of angle XST is equal to 125 degrees. All right. So that is the measure of central tendency. Now, let me show you this other thing real quick. When I say real quick, I mean real quick. And I'm probably going to continue on with it maybe later. I don't know about 1 o'clock. I don't know, because my day is just jammed up. But I'll see. I'll see what I can do. All right? Because by the time I come on tonight, you're going to be like, is Audrey okay? Did she officially lost her mind? Yeah, pretty much. Yeah. All right. So, like everything else, well, here we go. So the next part, and this is the part that a lot of my students was getting, the reason why I came on here, all right? Inscribed triangles. Now, with inscribed triangles, we have to deal with a couple of things. One, you're not dealing when you have a circle. I know this is not a perfect circle, but here we go. All right. Semicircle. All right. We're not dealing with the central angle. All right. What we're dealing with are basically two chords. And a chord is a segment that hits the circle in two spots. But these two chords has a vertex. Okay? So we're not going to have the measure of a central because my vertex is not at the center of the circle. My vertex is, I want to say, like on the back end, okay, of the circle. So we have like an arc, just like before. We have this arc here. And this arc is not going to be equal to this angle. Because you see, it's further back. Because normally it'll be equal here. But then we still have this remaining part here. And that means your angle is actually going to be half this arc. So let's say I want to call arc AB. Okay? So the arc AB is basically twice this angle. I should have made it AC. Okay, that's all right. I'm going to put a C here. Why not? Okay. So I want to say the measure of angle C is equal to half arc AB. So you can think of it that way. Another way of thinking of it is the arc, if I go the other way, is going to be twice the measure of angle C. So if I say that my arc is, I don't know, 20. If I'm saying that this arc is 20 degrees, the measure of this arc, the angle is 20 degrees. The measure of the arc is going to be 40. So if I said the measure of the angle is 20 degrees, your arc is 40. If I said the measure of the arc is 40 degrees, the angle will be half, is 20. That's what this is saying. Okay, did everyone leave? All of a sudden it's like, huh? Did everyone run away? Okay, I got a couple hearts in there. Purple nurple, like what did I walk into? You, okay, you walked into what's called inscribed angles. All right, so we have triangles in here. So with inscribed angles, it's always half the arc. We were just working on central angles. So with central angles, whatever the measure of the central angle, the same is your arc. Okay? So if the central angle was 100, your arc was 100. Now, when you're dealing with inscribed angles, the measure of the angle is basically half of its arc. The measure of the arc is basically doubled the angle. So let me just do one example and then I have to go. I will try my hardest to get back here at 1 o'clock. It might be a little bit after, but the insanity will begin. All right. So let me zoom in here. We have this lovely triangle, but I'm not looking at the whole entire triangle. I'm looking at this angle measure of 55. So in order for it to be an angle, I need this side and I need this side. So my arc measure is going to start here at X and goes all the way to this Y. They're giving me the angle, but the arc is not going to be 55 because this is not a central angle. This is an inscribed angle. It's hitting the back of the circle. Okay? So in order for me to find the measure of this arc, I'm going to have to double this. So what is 55 times 2? Yes, yeah, so it's long ago. Good. 110, 110, 110. So the measure of this angle here, or arc, sorry, is going to be 110. Just like what I said before, don't look at the whole entire thing. That's how you will find the arc measurement with an inscribed angle. But to solve this problem, let me do this. Let me cover up half the circle. So if this arc measure is 110, what is the measurement of the arc that's missing? I think some people said it earlier, but go ahead and say it again. Okay. It'll be Runaway Sisters. Yes, it'll be 70. Okay. Because we have a half circle. Half circles are 180 degrees. We know part of it is going to be 110. So you take your 180 minus your 110 to get your remainder of 70 degrees. Okay. All right, good. Good, 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 good. All right. Now, playing devil's advocate, because that's what I do. If this arc measure now, you're like, oh, Audrey, I know. If this arc measure is 70 degrees, what would be the measure of its inscribed angle? What would be the measure of that angle T? How would I find that? Runaway Sister, Albert. Hi, Albert. I don't think I said hello to you. I'm so sorry. My symbol's key. What are the steps to find that? Got Michael. Okay. So how are we getting these 35s? Because all we're doing is taking the arc measure and we're dividing by 2. Because the angle is 1/2 its arc. That's how we got 35 degrees. Okay. All right. I pushed it to the limit. I pushed it as far as I could. Ooh, wow, that was a major zoom. So sorry. You're probably like, I couldn't even see that, Audrey. Okay, so all we did. So I'm going to try. I'm going to try my best to come back and to finish the inscribed triangles. I'm going to try to do that maybe a little bit late at 1 o'clock, but I'll try because I have an appointment. And then I will see you later on this evening. I think I could be able to come on at 8:30 tonight because my 7:30 canceled. So you might be able to see me at 8:30 as opposed to 9:30. I know. That's why it's hard for me to keep a schedule because I just go through all this stuff. All right. So good. I'm glad it made sense. Thank you so much for coming in. Thank you, Allison. I didn't even see you to say hi. I'm so sorry. All right, not a problem. So I will try to come back on to do this. And I've been promising on logs and exponential, and that is going to be happening tonight. No holds barred. We're doing that. All right. All right. Have a lovely day. Thank you so much for the likes and thanks for stopping in, especially for some of you guys that this is your spring break and you're spending time with me. Love that. All right. I'll talk to you guys later on. Try for me around 1 o'clock. All right. Talk to you.